Okay, looks like audio should be coming through now. Let me know when you hear this. Okay, looks like audio should be coming through now. Great. Let me know. Perfect, okay. So welcome everybody to World Quant Office Hours. Apologies for the delay getting started there. Just having a little bit of issues with the stream video and audio and so forth. So appreciate your patience as we were getting that started. And so a little bit about today. In these office hours, we'll be doing a few things. I will take a look at questions posted in the World Quant Ask website, that sort of forum that you may have been using already. I know I did see some questions in there already. I'll also be monitoring the chat for the video to see if there are questions showing up in there. Given that we have just started the unit, I would imagine there might not be too many questions, I guess maybe regarding the material so much as some more administrative things. I'm happy to answer those as well, of course. So that being said, I'm going to double check the chat to see if anything else has, or if any particular questions had popped up. Looks like not quite. So in that case, a few things we could talk about. And again, if you do have questions, whether those are about some of the material we may have seen so far. Let's see. I'm looking at the stream and it does not appear to be out of focus on mine. So perhaps you might try adjusting the resolution on yours, or just checking the strength of your connection. But for what it's worth, I am certainly happy to zoom in. Which, at least even if it's maybe not the most crisp picture, should be easier to read just by way of being bigger text. Okay. So I had one question that came in: can we complete the assignment in a week or so? If that is referring to perhaps the current mini project, then I would say that's probably a reasonable time frame. If that's referring to the entire unit, I would say that to complete it in a week would be very ambitious. It's a fair amount of lecture content as well as mini project content, so I would certainly budget more time than 1 week. Also a question noting, will we be using the Titanic dataset? We are using a number of real-world datasets. I don't believe Titanic shows up in this module. I could be wrong. It might show up in one of the lectures, but we use a number of real-world datasets. I also would like to, let's see, a few other questions had come up. How do I get to the questions page? So for that, I'll direct us to for the home page for our Jupyter Hubs, which of course is wqu-ds.tditrain.com. So towards the bottom of this main homepage landing page, We note we have this message board at wqu-ask-ds.tditrain.com. And so if you follow that link, that's going to look like this. You'll sign in with the same info, I believe, or actually perhaps I think you will have gotten an email for the info for this discussion board. Let's see, and there was another question. I think, would this session be recorded? Yes, so someone asked if this is going to be recorded. And yes, so all office hours will be recorded. You will be able to find them also from this home page where we navigated to the question site. So we have this tab for video links, and this will take you to office hours as well as those lecture videos, and as well as a playlist for office hours. And if I'm not mistaken, actually I believe the office hours will just be kept on YouTube. So this video links document will be the place to go to access these office hours recordings later. So I'm asking, can we share the link for the lessons? So those will be given through your Jupyter Hub. Again, you would find those in Video Links tab from that main page. Your hub is at wqu-ds.tditrain.com. All right, a few other questions that have been coming in. Is competitive programming necessary? I don't know if I know exactly what you mean by competitive programming, but regarding the improving Python skills, it is certainly important to have a strong background or a strong foundation in Python programming. In data science, one of the major considerations here is writing readable, expressive, and basically easy to follow code, especially as you are collaborating with people. Well-styled, again, easy to read code. This is sort of a central idea in Python, and it's going to make it a lot easier for you to collaborate. Also, it will be easier for you to read your own code in the future. Regarding improving those Python skills, there are two ways one could approach this. For one, there is an official Python style sheet. Again, thinking about that coding style rather than perhaps knowledge of algorithms. This is called PEP 8. Oops, sorry, PEP 8. Doing a very good job typing today. 8 style sheet. And this is a fairly comprehensive document regarding style for Python code. This is very widely used. It's not the only style sheet. Oh, sorry, let me paste this back in the chat here. So this is the link for PEP 8. And this covers appropriate style for many different considerations in your code. So that's very, very helpful, again, especially as you're collaborating. Someone asked, is this DS1 or DS2? Apologies there. This is for module or unit 1, so DS1. Someone asked, what is the best operating system for this course and data science in general? Well, for this course, you will be using the Jupyter Hub server, or the notebook server we've provisioned for you on our Jupyter Hub. Strictly speaking, that does run on Linux. and however, you would be navigating it really just through the Jupyter Notebook file browser. In general, I guess the second part of your question, many data scientists use Linux or OS X. Windows is also fairly common. With many programming and software development workflows, Windows can be a little bit difficult, largely because the sort of terminal or command line operating system works very differently from that of Linux and OS X, so it's not Unix style. To that end, I would likely recommend Linux, especially if you were developing for, perhaps programs that would run on some external server. Those are almost always going to be Linux, so it's certainly a good operating system to get used to. Let's see. So following up on the competitive programming question, someone asked if solving problems in these coding challenge websites, Codeforce, LeetCode, HackerRank is a similar one. Is that necessary? I would say that, perhaps potential job interviewers are not going to necessarily need to look at, your stats or results on these kinds of websites. They are useful resources, these coding challenge websites, because they often, test and develop your knowledge of more classical computer science ideas and algorithms. And to that end, I would say that it is fairly common in data science job interviews to be given a coding challenge that is more classical CS, more algorithm-based, and perhaps less analytical. This isn't always the case, but a strong foundation in sort of classical algorithms is definitely a good thing to have. Someone also asked, can you access WQU, so the World Quant Jupyter Hub in the future, or do you need to save it into your own Jupyter notebook? So this hub will not be up forever. It will close after the last day to submit assignments. To that end, you can certainly download this for your own machine and run it in your own local Jupyter server. However, the mini projects will need to be run, between now and the hub closing. The mini projects do need to be run through this server because our grader is, web-based, and it's going to be sending responses from your particular Jupyter Notebook pod into our grader service. For everything else, you can run things locally, and we do have some instructions for downloading videos, for downloading course content. And I can post a link to download information. Just give me one moment. So here at this link, we do have and I will pull it up on my window as well. We do have some basic instructions for downloading the material. For the most part, you can use just this download button, just that you see in your Jupyter Hub server. So nothing perhaps too complicated there. It will simply compress everything in data course into a zip file and download it locally. From there, it's just a matter of running Jupyter Hub locally, which just involves installing the software and a Python distribution and so forth. Someone again asked if this is Module 2. Yeah, this is Unit 1. Someone asked, can we talk about the unit structure, recommendations on the studying process? So to that, I would point you in the, again, that home page, just the landing page for your server. There is a syllabus about most of the way down the page. This shows a sort of roughly week by week syllabus. There is also a schedule given in the video links tab, which we can take a look at in a second. But roughly speaking, it looks like this for the next 7 weeks. We do assign mini projects at various times. I will point out that these mini projects are all due on the same day, technically, in December that we looked at above. I believe it was the 5th. But we assign them at these particular times because, for instance, after this first module, you will have the necessary knowledge to handle these 2 mini projects. Likewise, after the second module, you'd have the knowledge for this mini project. With regards to the structure, recommendations, how to study, I would say, first watch the lecture videos. Try to follow along in your own notebooks. Perhaps if you have 2 monitors, that's a great way to do that. Certainly pause the lectures as you're going through, to give yourself a chance to investigate some of the code, maybe more line by line. While going through those notebooks as well as the mini projects, I highly recommend, Jupyter notebooks are an interactive, it is like an interactive format, so you are able to experiment with the code yourself, see what works, perhaps see what breaks it, and that exploration and developing that curiosity or intuition for the material is going to be very helpful as you go along. I would say to start the mini projects as soon as they're assigned. As you go through the mini projects, you may find yourself referring back to the videos or just the lecture notebooks. Certainly, there's nothing wrong with that. You may find yourself, looking at other resources, for instance, Stack Exchange. Again, this is something I would still recommend. Developing effective habits for finding and understanding Stack Exchange answers or other people who have had similar questions to your own and relating that to your own, solutions you're looking for is a valuable skill. I've been a data scientist for some time. I find myself looking things up on Stack Exchange and parsing and relating other people's investigations to my own on almost a daily basis. So I would recommend, relating the content to external resources as well. Sorry, just navigating the chat here. Someone asked just for clarification on the deadline. Yes, so again, last day to submit assignments is December 4th, rather. I think I said 5th earlier. All mini projects are due on this day. So if you find yourself falling behind at some point, or if you find yourself wanting to maybe revisit a mini project later, that's quite all right. But I would recommend working on them as they appear, in the suggested place in the syllabus. Again, for instance, after week 1, or I guess module 1, we assign 2 mini projects. As long as they're completed by the 4th of December, that's quite all right. But I would say to work through them sooner. Perhaps if you find yourself, perhaps something you might do is work through the mini project and, maybe you haven't gotten 100% or maybe you haven't gotten over a 0.9 on all questions. So perhaps closer to the deadline, you might go back through the mini projects and try to reach this threshold for passing with honors, which is requiring an average score of 0.9 or greater. And to clarify, yes, so grading is done on the basis of the assignments of those mini projects. Someone asked how many times can we attempt the mini project questions. So there is no upper limit on the number of submissions you can make. There is a rate limit. So if you try to submit an answer too many times, I believe it's 3 times in a minute or 50 times in a day, you will be rate limited and you will have to wait for that time period to basically restart. The intent behind this is simply that you likely should not need to make 3 submissions per minute. If you are doing something like this, perhaps you're sort of trying to brute force your way through a question, or you're not taking time to think, okay, what might have gone wrong there? Maybe which part of this should I change? So there's a rate limit. Someone asked if we'll see the score immediately after submitting the assignment. Yes, so on a question-by-question basis, and I can pull up a mini project here. On a question-by-question basis, and I'm going to submit an incorrect answer for one of these questions. In one of these mini project notebooks, you will see code cells that submit to our grader. I would also highly, I can never point this out enough, it's something that I forget to do often, be sure to run these preamble cells, in particular this one that imports the grader service. And as we work our way down, I'm just going to get the data loaded and so forth. But we will see a question, we'll see these cells that say something like grader.score. And these are where we pass in solutions to questions. So right here, for instance, we have sort of a placeholder answer that shows what the data structure for the answer should look like, just to sort of give you an idea as you're crafting your actual solution. And if we look at this, right, this is a list of tuples. And in this code cell, we submit this summary stats object into this grader function. And we get a score immediately. It's going to be between 0 and 1. This was a 0 because it was just our sort of blank placeholder. Otherwise, it's graded in some cases on an element by element basis, or perhaps on some threshold. Someone asked, how relevant are the mini projects to the lectures? I would say, I think a numerical scale is a funny way to put this, but I would say perhaps a 10. The lectures are designed to, cover with real-world data sets and into sort of the most important practical ideas and some conceptual stuff and some theory as well. Real-world settings and real types of problems you would have to solve. The mini projects require more than, regurgitating, copying and pasting material from the lectures, but they will rely very heavily upon the material covered in the lectures. Someone asked if this module will cover PySpark and Hadoop, and so it is not going to. This is going to go through some sort of fundamental Python foundations and some data wrangling with SQL, pandas, as well as sort of more generally wrangling data. Someone asked if we can try again on mini project questions if you're not satisfied with your score. You certainly can. So again, kind of the way the grader works, we can submit this multiple times. Let's say, for instance, I'd change this from a 0 to a 4. This is really, again, just our kind of placeholder answer. You would actually be solving it by writing code. But just to demonstrate, we can change our answer. We can submit again. I still got a 0 because I was just randomly changing the placeholder answer. But in general, you can keep going. Perhaps you got a 0.8. You want to get closer to a 1. In some cases, you can get above a 1. I don't know that that applies to this particular module, or this unit, rather. But yes, you can submit as many times as you want, and the grader will maintain your highest score. So if you got a 0.9, you tried again, and you got a 0 or a 0.8, your saved score would still be that maximum, that 0.9. Someone asked if, or mentioned getting an error while running the data wrangling code, importing something, executing 2 different cells. I could probably address that more specifically if you want to direct me to like a particular notebook and a particular maybe cell in that notebook. So we can follow up on that. Someone asked about Unit 2. Completing this unit, how do we get to Unit 2? So let's look once again at our sort of home page. I believe we make note of Unit 2 here, or perhaps actually not here, but rather, yeah, I suppose that is not actually mentioned on this page, so I will direct us to it. Yes, so you can apply to Unit 2 when you finish this module. I will paste the link to that in just a moment here. Again, you do need to pass Unit 1 to register for Unit 2, but you and so you would do that through the World Quant Apply website. And I guess that is going to be at, let's go in here, wqu-apply.thedataincubator.com. So this shows the schedules. There's also an apply page. Basically, applying for Unit 2 works like applying for Unit 1. You just will need to make sure you check the relevant box that says, I'm applying for Unit 2. Someone asked if the solutions for the mini projects will be taught. So these will not be covered directly in lecture or office hours. The mini projects are your assignments, and your solutions are evaluated according to the grader. Someone asked if Unit 2 is a continuation of Unit 1. Sure, in some sense I would say it is. Unit 2 is going to expand into further material. It's going to introduce machine learning, and it's going to be related a lot to machine learning, some natural language programming, and a little bit of TensorFlow. Someone's asking, are classical computer algorithms, heap sort, binary search, breadth first search, data structures like stack, queue, and binary tree applicable in Python for data science? I would say yes and no. You may not find yourself manually implementing these things a whole lot. That being said, a Python list actually does function as a stack and queue, and there are some other implementations of them. But things like heap sort, things like manually searching through trees and graphs, you might not do very manually. These are foundational computer science ideas, however, and they are relevant to familiarize yourself with. They may come up in interview challenge questions. If you're, if like the data science team or interviewer is maybe from a more classical CS background, they sometimes really like those kinds of questions. All right, so Kingston noted in the DS basic, DS module cell that you're having some trouble using NumPy. So, and I think someone mentioned this in the chat as well, that you may not have imported NumPy, so you may have missed a cell. So I believe this should be in DS basic, DS modules. So this is loading up, but based on the error message, so you have a name error, and it says NP is not defined. Typically, NP is how we're going to import NumPy. It's not happening in these first two cells, but rather, if we scroll down, it's likely that you may have missed this cell that says import NumPy as NP. If you are running this locally, if you have downloaded the material onto your own machine, then perhaps you might need to install NumPy as well. But most likely, if you're running it on your pod, then it would have been this cell for importing NumPy. Someone noted, did not see lessons specifically covering algorithms and object-oriented programming. So there is one for object-oriented programming and for algorithms. These are in the Python module. If you do not see these, perhaps you are in Unit 2, we're in Unit 1, but these should be in your Python directory in data course. So perhaps you might have been looking in data wrangling. Someone asked, are we starting with data wrangling? So let's refer back to the syllabus. Again, this is on your home page. And so, and these will be listed in the, actually in the videos as well in more specifics, but the first few weeks are more related to Python fundamentals. Someone also asked, do we do things that are a little bit closer to, building web applications in this? So really not in particular. Things like using NoSQL databases like MongoDB is going to be outside of the scope of this course. Likewise, building web applications and deploying on websites like Heroku is also not going to be in this course. I will say, as far as perhaps why we cover SQL instead of a NoSQL approach like MongoDB, SQL is still like the most widely used database paradigm. It's, I believe, actually in many studies of public job postings, something like the 5th or 6th most requested programming language across kind of all tech jobs. And it's typically something that's mentioned alongside Python, alongside Java, alongside really anything else. Someone asked if the lecture videos are updated every week. Yes, those are updated. How many mini projects are in this unit? So again, we can look, we could look at right here in the syllabus. We have 2 here, 3, 4, and 5. We could also see that by navigating through our mini projects directories, right? And I guess this is a notebook, but if we look at the, I don't know if it will like that link. Yeah, if we were to navigate through these 2 directories, we would see 5 of those. Let's see, yeah, someone asked, how do we save the mini projects? Yeah, so saving all of data course will save, everything, lecture notebooks as well as mini projects. The main difference with the mini projects is that the grader cells will not run because that is specific to the installation we have on our pods. Someone asked about about relevant Kaggle projects. I would always recommend Kaggle as a resource for developing your skills in data science. We don't directly, relate our material to Kaggle projects. I think some of our data sets are certainly also present in, Kaggle projects, Kaggle, kernels and so forth. So I don't know really particularly what I'd say. Kaggle's always good. Someone noted, can we add these projects in our resume? Certainly you can mention when you, have the certification for this course, you have been certified through World Quant University. You could, if you were adding line items below that, bullet points, right? You could explain some of the problems that you solved in the mini projects. And they certainly would be, relevant material to discuss with someone in a job interview, for instance. One of the benefits there of, working with real-world data sets and real-world problem types. Someone asked the best way to improve Python skills. I mean, there are many answers to this question. I think coding challenges are helpful. I think, reviewing your own code for style according to something like PEP 8 is very helpful. In general, after you write a solution, maybe do this on the mini projects. You have a solution that maybe achieves the score that you want, but it might be the case that as you built up your solution, maybe it got kind of messy. Maybe the variable names got confusing, or you had, complicated or inefficient strings of functions and methods. So I would say one thing you could do is when you have working code, consider, okay, can I rewrite this in a way that is easier to read or makes more sense, for instance? Someone asked my name. Sure, my name is Michael. I'm one of the instructors. You'll see me in office hours from time to time. I currently live in New York. I am not Dylan. Dylan is a colleague of mine who recorded many of the lectures. So you may see me in office hours. You may see my colleague Don or Russ in office hours as well. But it was Dylan who recorded the original lecture videos. Someone asked if they should finish Unit 1 before applying to Unit 2. Yes, I think you may be able to submit an application before that, but your admissions will be dependent upon finishing Unit 2, or finishing Unit 1. So I would say finish Unit 1 and then apply to Unit 2. Someone asked how to add libraries to test data wrangling code. A little bit of I don't know if I know exactly what you mean with that question. If you're on your Jupyter pod, then you just need to import those packages. We typically have those cells in the notebooks already, whether it's NumPy, Pandas, and so forth. Somebody is following up on where I'm from. Sure, I'm from Phoenix, Arizona. I've lived in New York for the last few years. Don't know how relevant that is to the course, but happy to address it, I guess. Someone asked if I could solve a mini project question and show you. I can't do that just because it is like the required assignments. I can maybe discuss conceptually what you might be doing, and maybe I'll look at the earlier mini projects, which I guess means we should be in Python. Right, my window is going to cut out for just a moment here because I'm going to be actually getting rid of a few lines of code. All right, so looking at this IP mini project, for instance, and turning my window back on here. So this first exercise, we're working with these Mersenne numbers. It's a mathematical concept. We don't need to do too much of the theory, but rather we'll be writing some Python functions that make use of this idea. And so for some value p, a Mersenne number is any number we can write as 2 to the power of p minus 1. So 3 is a Mersenne number, 2 squared minus 1, 4 minus 1, 3. 31, 2 to the power of 5 is 32, minus 1 is 31. 7, 2 to the power of 3 minus 1, and so forth. So we do a few things here. We need to write this function, Mersenne number. This takes an exponent p, and it returns the corresponding Mersenne number. And so really, in this function, we would just be implementing this formula based on some input p, right? We would be returning 2 to the power of that argument p minus 1. So just an integer, right? Once we have that done, we would say, okay, so a Mersenne number is prime, or it can be prime, if p is prime. So 2 to the power of 5 is prime. That's 32. 32 minus 1 is 31. 31 is prime. And what you're asked to do is to make a list of the Mersenne numbers for every corresponding to each prime number p between 3 and 65. So p is between 3 and 65, meaning you would have something like 2 to the power of 3 minus 1, 2 to the power of 5 minus 1, 2 to the power of 7 minus 1, because these are prime numbers. All 17 prime numbers between 3 and 65, those will be your values of p. But you want to use those and construct a list of the corresponding Mersenne numbers. And so it would have 2 to the power of 3 minus 1 in the list. It would have 2 to the power of 5 minus 1. And we have some examples here, just kind of covering list data structures. We ask you to write these two functions, is prime and get primes. And we note that actually there is a is prime function in the program flow notebook that you can make use of. And then get primes you may have to modify a little bit. And then, I guess this originally said 7 times 17. We have another dummy solution here, just a list of length 17 Mersennes. And if I submitted that dummy solution, I would get almost a 0, but it turns out that 7 is a Mersenne number, so I don't actually get a 0. All right, so that was an overview of what a problem might look like, the sorts of things you might have to do. Hopefully that is helpful. So there was a question, should we watch lecture videos before attending office hours? I would say that you likely would have relevant questions that arise when you watch the lecture videos. So yeah, I would definitely recommend watching those before office hours. Someone also asked, what would I advise to do after these 2 units to be ready for the professional world, specifically in machine learning? I would say maybe the biggest pieces of advice I have aren't only in machine learning. I mean, they relate to machine learning workflows if we were, deploying an application. I would say, becoming familiar and, I guess sort of fluent in using Git, especially on platforms like GitHub, which are widely used. And, getting used to that process, right? Like, working on a remote repository, working on a branch of a repository, creating a pull request to merge your changes in a branch into the master branch, these sorts of things. And there are a lot of great tutorials and resources on GitHub, for instance, for working with this. For use with Git, integrating that with GitHub and data science in general, I would say that it's helpful to be skilled at the command line with Unix style coding, writing shell scripts, and that sort of thing as well. Someone asked about my qualifications. Sure, I hold a master's degree in statistics. I've written R packages in computational statistics. I've been working as a data scientist for the last couple of years. Yeah, I have 3 years of experience in academic research at the graduate level, writing sort of externally used R software. I currently develop a lot in Python. I work a lot with, and then I teach a number of courses as well in data science. So I asked if Unit 1 and Unit 2 are enough, I suppose, for professional development. They're a very strong foundation. They teach the techniques and relevant concepts for much of what we need to do in industry data science. Enough is a funny word. I would say it's to anyone's benefit to always strive to keep learning new things. And then again, some topics like getting very familiar with Git are really helpful as well. Learning a little bit of web development is also great. And I know that Timur, I think you were the one who you asked about that question and also noted that you do work as a web developer. But for others, learning things like building a simple Flask app that you might use to demo a data science project you've done can be very useful. Someone asked, is there research work going on and papers published in data science regularly? Yeah, certainly. And this relates to a lot of different things. There's definitely a lot of active research in machine learning. Natural language processing is very hot. It's very well funded. Certainly, deep learning in general is very well funded. Deep learning is certainly not the only interesting or useful thing in data science, but it's, because it's at the cutting edge, it's certainly the subject of much research. Sean also asks, is there open source work with regards to data science? Sure. So, I would consider, things like much of Kaggle I would call open source because, people share notebooks they use to solve Kaggle challenges. So that's sort of, open source at the level of analysis. At the research level, it's sort of commonplace for academic researchers to share their code for, the purposes of reproducible research. So that is open source. And then furthermore, things like NumPy and Pandas and, many of the most commonly used, and including TensorFlow and Spark and so forth, packages that data scientists work with are open source as well. So you can inspect the source code, you can contribute on GitHub in an open source manner, and so there is certainly a big focus on open source here. Someone asked, if you know the answers before submitting the final assignment, you'd be good for 0.9. So if that's regarding, when you say submitting the final assignment, to be clear, when the grader gives you a grade for a particular question, this is actually all you do to make submissions. The grader is not like checking your work before you submit this notebook, for instance. These grades are directly entered into our grader service database, so it's all you have to do. Sean asked about open source. How might we go about contributing to things like pandas and NumPy? I don't know that this would relate necessarily to things you would do in units 1 and 2. Pandas and NumPy are very mature packages at this point. They likely would require a decent amount of software development skills to work on. But we could look at, for instance, the pandas GitHub. And in general, in an open source workflow, a good way to start would be to look at active issues. And typically in large-scale open source projects, these might be tagged with something such as, there's often something like good first project or good first issue. And you may find some of these that are active that you might be able to take a look at. So for instance, adding some documentation for a particular example. Maybe there are some bugs you could take a look at, and so forth. That's auxiliary to the content in this course. I think it's a good thing to mention. So for instance, this particular issue is just asking, we should add some examples to the doc string for this method. And that's something that someone could work on. But again, kind of external to what we're doing in this course. So I'm asking if you can apply for internships after Unit 1. I don't know if you have a particular internship sort of thing that you're referring to. But if the question is Unit 1 perhaps offering qualifications that would be good for an internship? I would say certainly. It covers a lot of relevant topics in data science. You may want to get through Unit 2 as well. Machine learning is a big part of what we as data scientists do, so I would say perhaps do that one as well, but not to discourage anyone from applying for jobs or internships before then. All right, we'll be wrapping things up in just a minute. So just as a quick little roundup, again, many of the resources or many of the questions that people often have can be answered just through the info tab on the homepage. This covers, sort of timelines, syllabi, and so forth. A lot of this information, and especially as it pertains to syllabus information, will be emailed out every week as well. Then I also want to point out once again that questions page, WQU askds.tditrain.com. I and my colleagues will be monitoring these questions as well and answering through the message board. But we also find that you are valuable resources to each other. A lot of the times, by the time I see a question and I go to answer it, there are already a number of great responses that actually address the question and fully answer it. So I would say, I really, really encourage that, and I would recommend, to each of you as well, that answering your peers' questions, on this message board actually is a phenomenal way to improve your programming and data science skills. I'm a big proponent of the idea that the best way to learn something is by teaching it. It's certainly been my case, whether it's been teaching data science or mathematics or any of the other sort of teaching roles I've had in the past. All right, but that is going to close up for today. We'll have another office hour at this time on Wednesday, and we'll have office hours tomorrow and Thursday at 4:30 p.m. Eastern. All right, thanks everyone.